And the purpose of these slides are to discuss the general structure of a model and how the model in algebra translates into a model in matrix format, and the properties of the matrices that link the endogenous variables to the exogenous or predetermined variables. So I'm using a very simple stock flow consistent model made only of the private sector with consumption and investment. And I have used two very simple equations for consumption and investment. And I wanted to have the model to be dynamic. So I'm using lagged variables on the right-hand side for consumption. So here, this is rather standard. The consumption depends on income and the opening stock of wealth. Investment depends on capital output ratio. So if beta y is the desired level of the stock of capital, investment will be a fraction of the gap between desired capital and actual capital. And then we have the standard accounting identities for the accumulation of capital without depreciation, wealth coming from saving, etc. So if we substitute the identities into our equations, and I think in the first slide, so in the first line, I simply use the fact that in this model, the stock of wealth will be equal to the stock of capital. So consumption depends on the stock of capital. I have got rid of investment as a variable, and I substitute the change in the stock of capital to investment, so that the equations can be rearranged in this way. And I can finally bring the endogenous variables, which are only two, which are consumption and the stock of capital, to the left-hand side of my system, and the other variables on the right-hand side, and this will be the lagged values of consumption and the stock of capital, plus the two constant terms, C0 and I0, which summarize exogenous variables, plus the random components of consumption and investment. We can normalize the system by dividing the first equation by 1 minus C1 and the second equation by 1 minus I1 beta. And the final system can be written in this way. And we can further simplify by substituting these fractions with other parameters, so that we can rewrite the model in this form. And since we have normalized the first matrix on the left, which is the matrix of the parameters giving the contemporaneous connection between consumption and investment, will have only one on the diagonal, then these will depend on the lagged values of the endogenous variables, plus a vector of exogenous variables, plus the random components. This can be written in two ways. On the top, I keep separated the exogenous variables. On the bottom, I've included them in a way which is similar to estimation, where you have the constant written as a 1, as a exogenous variable equal to 1. And this system can be generalized, saying that any system of equations can be written with a square matrix R, which contains the coefficients which link the endogenous variables in the same period, matrix gamma, which links them to the previous value of the endogenous variable, and a B matrix, which links them to the exogenous variable, plus a vector of the random terms, so that in matrix algebra, the system has a solution if you can find the inverse of R, and it will imply the last line where the gamma prime is a new matrix with the same size of gamma. The B prime is the matrix with the same size of B, but they will be combination of the parameters in R and the parameters in gamma and B. And also the error terms will depend on the inverse of R. And as you already know, I guess, the model in the first line is what we call the structural form of the model. And the model on the second line is what we call the reduced form of the model. So in the reduced form of the model, each endogenous variable depends only on lagged values of the endogenous and on the exogenous. And this story is useful to understand a number of things, which is the first one is that the solution will depend on the invertibility of R. And this implies that you don't want to have linear dependencies among your endogenous variables. The second one is that if we need to estimate these parameters, the standard econometric approach says that we cannot estimate the structural form directly, because if the R matrix is a full matrix, we will have endogeneity of the regressors. So in our case, consumption will depend on the stock of capital, and the stock of capital will depend on consumption. So you cannot estimate the equation, the two equations directly in structural form, but you can estimate them in reduced form. The problem is that the parameters you get in the reduced form are those in the matrices gamma prime and B prime, and they are less than the parameters in R plus the parameters in gamma plus the parameters in B. So you have the so-called problem of identification. So you cannot obtain the original parameter in the structural form from your estimates of the reduced form. And this gave rise to different strands of literatures, because first of all, the critique which was made to the Keynesian models to begin with is how can you separate the endogenous variables from the exogenous variables? So in principle, we cannot deny that everything is interconnected. So if we don't have exogenous variables, but only endogenous variables, the problem becomes even worse. We should treat everything as potentially endogenous. And if you drop Bx or B prime X in the next slide, what you get is a system of equations where each variable depends on the lagged values of all the other variables. So you get a var, okay? And many macroeconomists abandon the standard Keynesian approach of the structural form to adopt vars. But then they realized that in the var, you have this problem of identification, and therefore you cannot estimate the contemporaneous link among your variables. Now, is this important? And the answer depends also on the type of data you are using and on the frequency of the data that you are using. So if you are working with a model of monthly data, it may be realistic to assume that, let's say, consumption in February depends only on the income in January and December and November, but not on the income in February. But if you're working with annual data, then it is obvious that consumption in 2022 will depend on the income in the same year. So in most cases, we don't want to lose the estimate of the contemporaneous link among variables. And so the mainstream switched from vars to so-called structural vars. And the idea is that you impose restrictions on the gamma prime and B prime matrices so that you can identify the original parameters in the structural form. And Romer wrote a nice piece, which I think is related to this story. So Romer, there are two Romer, but the one I'm talking about is the one who became head economist of, don't remember whether it was the IMF or the World Bank a couple of years ago, the World Bank. So when he got appointed, he wrote this paper that he published on the web saying, now that I'm no longer an academic, I can finally talk about my colleague who do macro. And I think they are doing nonsense because they criticized the old style Keynesian approach. The old style Keynesian approach was using models in structural form and arbitrarily imposing restrictions, which were quite clear in the way the model was presented. And this is what we have done in the last few days with the model of Mexico. So we said arbitrarily that private expenditure depend only on income and wealth, that employment depended only on GDP and possibly wages, and we neglected all the other endogenous variables in the model. So Romer says, in the good old times, the Keynesians were making arbitrary assumptions, but they were clear and transparent. The structural vars are doing the same, but they are hiding their assumption in some obscure parameter in the structural form. So it looks more scientific than the old Keynesian approach, but in the end, it's as arbitrary as what the old Keynesians were doing, and it's also less transparent. So I thought this would rehabilitate somehow the Coles Commission, as it's called, the approach that we have always been using, but I don't think this is happening. So it's still true that if you write a paper using a structural var, you have a much higher chance of being published than if you write an empirical paper using the method that we have discussed. So this is one of the things I wanted to discuss with you. The other is that this R matrix is what is linking our endogenous variables. And most of the problems that we may have when simulating a stock flow model is that the solution to the system, when the R matrix is full, needs to be obtained through an iteration procedure, which looks for parameters which get a solution. And it is not certain that you will find a solution. Sometimes the model would not solve, And when this happens, the standard suggestion that we have, and the one that Godley always used, is to reduce the degree of interaction in the model. So how can we do that? So let's go back to the original model here. So here, one of the strong interaction is between consumption and income. So one way to reduce this is, if the system is not solving, is to momentarily assume that consumption depends only on lagged income. So at that point, one of the parameters in your R matrix goes to 0, and the R matrix becomes triangular, as we say. Or we could do the same with the investment function and assume that the adjustment to the gap between desired capital and actual capital happens with one period of lag, and therefore, again, you put to 0 one of the parameters in the R matrix. Now, when you do that, the system becomes completely recursive. So each equation can be obtained only from the exogenous and lagged variables, and you can always solve it. So what Godley taught me is that this is a way to go if the model is misbehaving. And the model may be misbehaving also because, let's say, you have this kind of model where you have both the Keynesian multiplier and an accelerator. So it may be that these imply too strong a reaction of GDP to a shock, which is not realistic. And by using this trick of lagging the response of one variable, you can try to verify what will imply more realistic outcomes for the model. And last thing which is connected to these stories is the stability of the solutions. Now, usually this is more of a problem when you do theoretical models. In theoretical models, the parameters you have chosen may imply an unstable solution, so the software would not solve. It once happened to me that when I want to calibrate a theoretical model, what I do is I start from my balance sheet. I put numbers in the balance sheet which match, which respect the consistency. Then I compute the implied payments in the transaction matrix, make sure that they are consistent. And I do all this by using some reasonable parameters for my equations, and using algebra to find for simple models, to find the long run solution. So the values I'm giving, let's say, to the stock of wealth relative to income are what the model should produce for the long run solution. But it may happen, and it happened to me once, that the solution is unstable. So the algebra tells you what the solution is, but unless you do the stability analysis using algebra, you don't know whether the solution is stable or not. And this implies that you have a nice model running smoothly, giving you a nice steady state. But when you shock the model by a small number, then the solution explodes, and the shocked model is no longer stable. So the other thing you may want to do, and I think you are actually required to do to publish a theoretical model in a journal, is also to verify if the system is stable and what are the parameters that imply stability for the model, or different regimes for the model. But I'm not going to cover this here, and I think maybe some of you are even better than me in finding this algebraic solution using eigenvectors, eigenvalues, and all that stuff. So this is it. Do you have questions? So as I suspected, everything was already clear. Okay, so we can go back to our Mexican model, and we need to decide on what other games we want to play with these numbers. So we were quite unlucky yesterday because everything we tried was not giving us very good results. We now have 47 equations, and we have endogenized wages, and we have endogenized the wage level relative to wage growth, but we were unable to find the determinants of wage growth. And we have endogenized employment, but it was not so, I was not so happy with the equation for employment, which implied an increase in employment if the real wage went down. So the two things which may be interesting to do next are one which is related to capital gains that we have neglected so far. And the other is an attempt to split the economy into what we could call the informal sector or the small firms. Since we do have the data for the GDP of the household sector, which, as I told you, is an estimate of how much of GDP is produced by very small businesses. And we could try to check whether splitting the GDP in these two parts and having two different measures may help us get something reasonable for wages and employment. But I would start with the capital gains. So the idea here is that I think my balance sheet was here. No. Yes. So this is our current balance sheet. And we have estimated everything at historical prices. But in principle, we have the measure at current prices in the data. So we can try to obtain estimates of the implicit price of the stocks and therefore on capital gains. And we could check whether these capital gains matter for the behavior of our equations, in particular for the private expenditure function. So what we found for the US, what Godley found for the US in his 1999 paper was that, as you know, the model was based on the idea that the stock of wealth relative to income should stabilize when the economy is growing at a stable rate, but that was increasing. So the reason why that was increasing was linked to capital gains. the net capital gains in the stock market at that time. It was the dot-com bubble. And the same, and in addition, you had this effect from borrowing. So I godly added another variable in the private expenditure function, which was the change in debt of households and firms against the banks, with the idea that if this increases, you can have an increase in consumption or investment relative to income. This is also a tricky story, because if you are assuming, well, if you want to estimate consumption on the basis of borrowing, then you have to be careful on the direction of causality, because if you have access to credit and you decide to spend more and take a loan, and you have no restriction on the amount you can borrow, then it should be consumption to determine the change in your debt. On the other hand, if you are constrained on the amount you can borrow, then you can consume more only if the banks gives you more credit. So in principle, you'd like to consume much more, but the banks are restricting credit. And in that case, the causality should go from credit to consumption. So only in the second case, you can use the borrowing in a consumption function without an endogeneity problem. So we can try to see what we have here and check whether this is relevant for the model. And we will have to do a little work on the data. And I think it should be particularly relevant for our foreign assets, because as we saw, the change in the stock of foreign assets is very different from the balance of payment. And this implies that there is a lot of volatility, which may be also relevant. So we will need to go back to our huge data set. Let me increase somewhat. And what we need to do is to consider the components of this stock. So let me take the program that we are currently using. So I think in here, yes, in here I estimated the wealth of the foreign sector by taking the line 6205. 6205 is the total assets of the rest of the world, less the total liabilities of the rest of the world. So what we could check to begin with is what if we take these assets and liabilities separately, and we check the discrepancy between the published figure here and the figure we can estimate at historical costs. So in that case, we will want to have a series that we can call a foreign debt, and this will be the assets of the rest of the world. So it will be V6205. and we want the assets of Mexico, which are a debt of foreigners, and these are as 6212. And we could call these 4 assets. And now we want to look at this in as they're published, but we want to also accumulate them in our system here. And here we were using our consistency requirements to obtain the net assets of foreigners, but now we can use the data. So we can say that 4D and 4AS, so this should be the flow fund measure of the change in the assets of the rest of the world, and this should be the flow fund change in the debt of the rest of the world, and I have to find where these are reported. And this should be the financial account here. So it should be these lines for assets. So this should be what we have as foreign debt. It's V3940. And this should be the assets of Mexico, 3956. So that now we can have for 2008, we can set foreign debt 0 equal to foreign debt, and foreign assets 0 equal to foreign assets. And then we can have in here, actually, let's call this foreign debt at historical prices and foreign assets at historical prices. So that foreign debt at historical prices increases with the flow, and the same for foreign assets. Sorry, here I want a -1. So I hope what I did is more or less clear. And what I've done is to obtain, to take from the data the measurement in the balance sheet and estimate the end of period stock by accumulating the flows. So now we have 4DE and 4DEHP, but something didn't work here. D3940 is empty. This is because they're using, they're publishing only the net change. Okay. So the only way we can go here is to either, I think we should have for AS. Yes. So what we should be able to compare is there's nothing. So these are the figures published for the debt of Mexico less the assets of Mexico. And it should be comparable to what we called VW. And yeah, this is showing how far we are from the actual data in the balance sheet. So if I didn't do anything wrong, the blue line should be the debt of Mexico, which is an asset of foreigners, less the assets of Mexico, which are a debt of foreigners. And this was our estimate of the two, but they are completely different. And I must say that this should not be the case for the starting values unless we did something wrong. And this something wrong may also be the consequence of the statistical discrepancy, which is the variable we had in here, V6356. Yes. So I think if we add the discrepancy to our measure, at least the two measures of the stocks start from the same point, but then one goes up and the other goes down. So this is going to be a little boring to try to build these, reconstruct these figures if we want to have the measurement, because assuming that this is how we should measure the net wealth at current prices and the net wealth at historical costs, then the gap should be given by the growth rate of the price of net foreign assets. So let's see what happens if we compute the gap between our stock measured in this way and the stock measured at historical prices, and we divide it by the opening stock. Now, this is a measure of the gap in percentage of the opening stock, and this should be linked to the net capital gains. But as far as I remember, the exchange rate was not going in a way which would help us explain this type of capital gains. So let's look at the rate of change of the exchange rate. Why is it not defined? Because it's in a different page. So I'm looking at this measure of the net capital gains, which is the blue line, and the growth, the annual change in the exchange rate of the peso. But it's very difficult to think that I can explain the blue line with the help of the orange line by itself. So it's going to take too long, I think, and I'm not sure it's going to help us that much. We could try to focus on one particular asset, like government bonds. So government bonds are in lines B6 to 5-7, and we identified the we already constructed the series at historical costs. So in this case, the measure are very close. So this is the blue line is what is reported for the market price of government bonds, and the orange line is the result of the accumulation of emissions of bonds, but now the discrepancy is quite small. And for this type of asset, I would not expect to have a large gap. So we could check whether the same happens for the bonds held by foreigners. And now this is interesting because now this is the value of bonds held by foreigners at market prices is the blue line, and the value of these bonds held by foreigners at historical costs is the orange line. So here we do have capital gains after 2014. So let's see what happens if we again take the gap between the two. As a percentage of the previous period, and we compare this to the exchange rate change. Here I'm using two scales for the two variables. And here we may have something that's not so clear, that the blue line can be completely determined by the changes in the exchange rate. I hope it's clear how I'm trying to work with these measures, but maybe we can try to work this out. So what I'm doing is I have a price of bonds multiplied by the value of bonds, and this is the what is published in the balance sheet, and this is the result of the appreciation of the existing stock of bonds plus the change in the bonds during the period. So this should be the measure that we have in the balance sheet at market prices. But what I've done is to compute a measure of B, let's call it B or whatever. Basically, what I've done is to have let's call it P prime B T equal to P prime B T minus 1 plus dBT, and this price here has never changed from the beginning. So what I have for my estimate at time t will be equal to the starting value of bonds in period 0, period 1, let's say, P0 plus the change in period 1 plus the change in period 2 plus change in period 3, etc. So the difference between the current price measure and the constant price measure should be the revaluation given by these prices. So by subtracting the first line, subtracting the third line to the first line, what I should obtain is a measure of the increases due to the change in the price, and by dividing them by the opening stock of bond, I should get a measure of the exchange rate. So this is what I've done in here. I don't know whether you can read it, which is to take the BW0 is the measure at current prices, BW is the measure at historical costs. So this should be an implicit measure of the price appreciation of the government bonds. I don't know whether this also applies to BP.
Like theoretically, it could be also depreciation, right?
Yes.
Depreciation, but just for billion.
Yes, this is because it's always positive. So the price of bonds must have gone up over time. What we should also check is what happens to the other side of the market, so the bonds held by the private sector. Here, the exchange rate should not really matter that much. So this makes us suspicious that this is a good way to measure these capital gains, because what this is saying is that the capital gains of the foreigners are a capital loss for the holders, domestic holders, and this is not what should happen if we're properly measuring these things. So I would really give up also on this attempt. We could try to check if what they publish here is useful. So as I told you, they have the financial account. So this should be the flow of borrowing and lending for each asset. Then we have this funny account that I've not met in other countries. So the Aparición Económica de Activos is, and I guess of debt is, I think, something they use when the measure of the asset is larger than they expected and they don't really know why. And so they say, okay, there's some additional asset that has appeared. Also for the real wealth. And the Desaparición Económica is the disappearance of debt. Now, this also should also be related to bankruptcies. So if you have a debt and you cannot pay it back and you default, then the stock of debt and asset will drop for this reason. This riesgos catastróficos is the loss in the value of assets due to some catastrophe. Expropriation without indemnization is another feature I've never seen in other countries. And other changes in volume is also something that they record, but they don't really know how to explain. And this again, cambios de clasificación. I think, is what happens when the flows tell them that, let's say, the household should have that many bonds, but then it happens that these bonds are not in the hands of the households, but in the hands of another sector, say the foreign sector. So they reclassify this in a different way. Other changes in volume of assets. And I think that what we are looking for is this cuenta de ganancias, should be the capital gain. So let's look at the same things we were trying to estimate. So we were looking at the government bonds. But they're not detailed, actually. This is what they report for the net capital gains of the foreigners, and it's always zero. It's V5549. So this is what they report for the net capital gains on assets of the rest of the world, but it doesn't seem to have any resemblance to what we were trying to measure before. Let's see if they also have the, yes, they also have the loans, the debt in 5556. So this is what they report as the net capital gains on foreign wealth, and this is what we have as the difference between should be the difference between the change in the stock at current prices less the change in the stock at constant prices. Okay, so now I got it right, and this is what they report, and I think now I got the right way to measure it with our model variables. So this now looks pretty consistent with the data. But again, if we...
Not much at the beginning.
Not in the beginning, yes. Again, if we try to compare this to the exchange rate changes, I don't think we will have anything interesting. Let's have the quarterly growth rate in the exchange rate. And yes, you cannot really tell other than for this peak, which is the same here. The movements are in the opposite direction. The correlation can be obtained here, and it's 0.16. So this is not really telling us that much. Okay. So let's discuss how we want to proceed, because I think by now you understand that extending the model will require that we lose not so small amount of time in looking at the data. And given the quality of this data, the chance that we get something useful and interesting is not so large. So, given that I've covered everything I wanted to cover, now I'm at your disposal to discuss whatever you think may be useful. Yes.
First, I really like what we discussed at the beginning of this model, this simple theoretical model, which is simple and more, we understand it. But I thought, wow, that would be interesting if we simulate that.
If you simulate that, yes. So, yeah, we can switch to theoretical models.
Maybe the other different taste or opinion, but I really like this initial part. Yeah. Also,
okay.
But this is more trial and error. It's more.
Yeah, this is more working on the data, and that requires time. Yes, more time, the less, you know, trust, the less you can trust the data. Yeah, we can switch to theoretical models if you want, but to simulate models or to discuss how to set them up.
I would say both sounds very interesting.
Both, I would say. Start with how to set it up and then try to simulate it. Maybe even, I don't know in which language, in R would be maybe good.
Well, we can do it in both EViews, and there is this package for doing theoretical models in R, which is very good, but I've never used it. I used it only for verifying how it works, and it works quite well. And yes, yeah, there the real problem is the parameterization that you want to find. So we can discuss this. Okay, so you want to start from a very simple model. Okay. So let's take a short break and then we continue. So we can now close all this stuff about Mexico.
It's a bit too complicated to also split households and
Well, households and business. Yeah, we can do that. I hope it's not going to be complicated to find the analytical solution.
Exactly.
So usually you want to start from the balance sheet. So what assets do we want to consider? So should we have loans, deposits, and bonds, and that's it? So we can say deposits are taken by households, loans, let's say that are only taken by business, and bonds are, say, only held by households. Okay, so net wealth would be VH here, and as I said yesterday or the day before, we have to decide whether all of the investment is financed by loans, and therefore we have 0 here. Or if we have retained profits, and then here we will have the net wealth of the business. So I don't know, we can try to do this. This will be 0, and this will be minus b, and this has to be k. We
considering retained profit.
is considering
Investment financed by
retained profits and loans. Yes. So how do we want to start the equation? So you suggest that we avoid using the package. So
The way we proceed usually is to create the placeholders for each variable, and maybe even for the parameters.
okay, well, let's first do the transaction matrix, which corresponds to this simple model. So I always want to have production separately from the other accounts. So here we will have wages. Let's call this WB, which go to the households, and profits, which we could call, let's call them GOS for gross operating surplus. And well, let's do without the net indirect taxes. So this should sum up to GDP. And then we want to have the interest earned on this. So
But then the government is always in debt.
yes, no, not necessarily. Government spends.
Depends on what he spends, yeah, but if he spends, he will be issuing bonds. Right?
Yes, yes. So here we have the interest payments, and the households will gain from. So we'll have interest obtained on deposits, which are paid by the financial sector, and interest paid on loans, which are gained by the financial sector, and interest obtained on bonds, sorry, which are paid by the public sector. And this is it for payments. So here we want taxes. All of this should be 0, obviously. And now this should define disposable income, but we want to have the payment of dividends, I think. So if we have dividends, they will be gained by households, and we will want to have the bank dividends. And we usually assume that all profits made by banks are distributed, so that there is no retained profit for the banks, the banking sector. And now we need to have the expenditure, so we will have consumption. We have to have investment, let's call it I. and we want to have public expenditure. And this should lead to the net lending of each sector. So the sum of the first column now should be 0. Here we will have saving of the household sectors. Let's call this save H, save business. This is 0, and this is saving of the government. And these are not things that we want to sum up necessarily. Actually, if I have saving, I would have the investment next. So let's call this net lending rather than saving. Net lending of households, net lending of business, net lending of the government. And here we want to have the change in deposits. Let's call this D. The change in loans and the change in bonds. So they are written with the opposite sign because so the total here will be 0. Okay. So next thing is how does this translate into a list of equations? So let's do this in a simple text file to begin with. And we can follow the standard notation we used before. So GDP will be equal to consumption plus investment plus government expenditure. And we will have that profits are GDP less the wage bill. Then we need to specify all these interest payments, but we will want to have a measure of disposable income. And disposable income is logically appearing in here as YD of households, and it should be the sum of these components. And here we want to lag the stock on which we compute the interest payments. And then we have the net lending of households given by disposable income less consumption. The net lending of business will come from here. So the NL of business would be the surplus, the operating surplus less what they pay on their loans, less the dividends, less investment. And the net lending of the government will be G. This would be tax less RB times B less G. And for the financial business, we will have that the dividends paid are equal to RL times L minus 1 minus RD times D minus 1. So I think this is all we need for the flows here. And then we have the flow funds. So the flow funds tell us that the change in bonds demanded by households plus the change in deposits must equal the net lending. And given the structure of the model, unless we want to set a price for bonds, we can assume that the change in bonds issued is equal to the negative of the net lending of the government. So this can be rewritten by bringing the opening stock to the right-hand side. And then we will have that the wealth of households must increase over time with the net lending of households. So now we have endogenized this part and this part so that the amount of deposits will be given. So the deposits can be obtained by the difference between the total wealth and the stock of bonds. Now the accounting of the model implies that the stock of loans must be equal to the stock of deposits. We could put it explicitly in this way, but not necessarily. So what we wanted to assume instead is that there is a demand for loans. So the change in loans is equal to investment less the net, net lending of the business sector. No, it's not the net lending, but what we could call the disposable income of business. So the disposable income of business is what is left from profits after paying for interest on previous loans and after distributing the so we want to also have the is YDB equal to profits less interest paid on loans less dividends. And we said that a fraction of this is used for financing investment. And therefore, I think we could write here that this is given by investment less the retained profits, so the disposable income of the business.
So whenever investment is larger, then we will take the loans.
Yes. If investment is larger than retained profits, the stock of loans increases, otherwise it decreases. And we will have the hidden equation must be that deposits are equal to loans. But we don't need to specify that the loans are equal to deposit as an equation. So what else do we need here? I think we don't need anything else from the accounting. Okay.
The government?
The government is here, so the change in the debt of the government is equal to the deficit. So
G will be exogenous.
G will be exogenous. So the next step is the behavioral we want to use. So let's start from the simple things, which are the tax can be endogenized with a parameter on the pre-tax income. And the pre-tax income is given by this less tax. The dividends paid by the business sector have to be a fraction, let's call this sigma, of the profits less net of interest payments on previous loans. So this sigma will determine the retained profits as a share of total profits. And what else can we easily endogenize? I don't think we can endogenize anything. Yes, we have to endogenize the income distribution because now WB is exogenous. So simple way that we can work on later is that this is a fixed share of GDP. And then we may want to discuss later what determines this. And now we need a consumption function. So the standard is to have, let's call this C1 times YD plus C2 times VH minus 1 would be the standard simple stock flow approach. And the tricky thing is usually investment. So yes, so, oh, actually I forgot the accumulation of capital. Now, this is always something a little complicated in theoretical models because if you have depreciation, then usually the model can converge to a steady state where investment, gross investment is equal to depreciation and the stock of capital remains constant. If we don't have depreciation, the stock of capital is going to grow forever. So we're going to have a growth model and we need to ensure that everything grows at the same rate as the stock of capital. So for instance, we cannot keep the government expenditure constant because it would be reduced as a share of GDP if investment is not zero. So what we usually want to do if you want to have a steady state rather than a steady growth is to assume a depreciation rate. So let's call this the depth R. And the steady state will be reached when investment is equal to depreciation. So now we can try to have an equation where we have a stable stock of capital relative to GDP, more or less the way I did in the slides for Mexico. So this could be an I0, or we could actually use the concept of the utilization rate. So I have a utilization rate given by a function of GDP over the opening stock of capital. Sorry, no, this should be the desired utilization rate should be written in this way, and let's call it UR desired, and then the investment would be modeled as a function, don't know, gamma, of the gap between the desired utilization rate and the actual utilization rate. I'm not sure that this is ever going to work. Because this is implying that if beta is larger than 1, investment will always be positive and equal to gamma times beta.
But we need some potential GDP.
I think we have to rewrite this in another way. So we say that the stock of capital at time t will increase by a fraction of the gap between the opening stock of capital and the desired what I call beta times GDPK, GDP minus 1.
Beta is the capital potential output coefficient.
Beta, yeah, should be give us the potential, so the desired stock of capital relative to the actual stock of capital, or we could use the concept of so-called capital productivity. So if the stock of capital is not totally used, you have that output is below potential with respect to an average ratio of output to capital. So let's try to work this out. So let's say that KT is the total stock of capital which is available, and then this, let's call this beta is the capital productivity. So this means that potential GDP should be equal to beta times the total stock of capital. Okay. Now, since only a fraction of capital is being used, so let's call K use the actual stock of capital. GDP has to be equal to beta times this K actually in use, and No, yeah, the first one is GDP potential. No, I'm just no, but I'm not going to use these equations. I'm just thinking while speaking out loud how we want to model the demand for capital. So basically, if GDP is below potential, you don't want to do investment because you already have too much capital. So the investment should increase with when GDP is above this potential. So when this beta times KU is larger than beta times KT, and what we usually have is so this would fill completely the gap between the two measures. So we can imply that this is not filled completely. Now, the
KU would be the K. Not the
KU has to be derived from here. So the capital currently used is given by the actual output divided by the so-called capital productivity. And therefore, we can get rid of this KU and only have here GDP, while KT would be the total stock of capital which is available. So again, we can get rid of the T, and this should be our investment function. So it's a link between the current level of GDP and the existing stock of capital given an average capital productivity. Now, this is going to have a strong feedback with GDP because I determines GDP, GDP will determine investment. So we may want to check later whether this works or whether we want to lag everything. And the other thing is in here, we have not considered depreciation. So usually what you want to do is to add the depreciation that I called deep R. So that investment is the depreciation that you need plus any gap between the desired and actual capital output ratio.
But is not already considered in the capital stock, capital accumulation function?
No, actually what will happen is that when we substitute this equation into here, this part will disappear. And you have that net capital increases by this amount. So let me do the algebra. So if we take this equation and substitute this one in here, so this part is equal to this dpr times k minus 1. So this simplifies to this equation here.
But if they're both, they're not positive?
What is not positive? The capital stock, yeah, it will be positive. Anyway, let's try to.
No, because it's k minus 1 times minus, this is multiplied by minus depreciation. So no, it's negative. Fine.
Okay.
Yeah.
Okay, so now we have the two equations for which we want to have parameters. So what I usually do at this stage is to use the spreadsheet to try to find reasonable values for all variables, starting from a benchmark. So the benchmark, it can usually be either GDP or the stock of capital, and the two are usually related. So the way I proceed is I copy this sheet to a new sheet. And here I start putting numbers and parameter values, so to fill the two matrices with numbers. So let's say that we want GDP to be equal to the stock of capital. I already know this is going to create some problems. So let's say that this is equal to 1,000. Now I can use a feature of the spreadsheet which allows me to give a name to a cell, so I can use the name in other calculations. So let's say that this is equal to the stock to GDP. And this will be equal to GDP. Now, the next step would be to define these other measures. So let's start by assuming that the stock of wealth of let's just say that the stock of bonds of the government is, I don't know, 30% of GDP. So what I've done here is to say K is equal to GDP. Let's say that bonds are 30% of GDP. And I can plug it into here. And this will be has to be the negative of this. This has to be the sum of the elements in here, and the same for the other columns. So now I want to have a measure for deposits, and this will depend on the loans, and these will depend on the starting value for the business wealth. So let's start from the idea that the wealth of the business sector is zero, and then we will see this will not be the case if we have retained profits. But if this is zero, then this must be equal to the stock of capital with the opposite sign. And this has to be the negative of this one, and this has to be the negative of this one, and this has to be the negative of this one. So we have found the value of wealth, which is implied by the hypothesis that the debt of the government is 300, and we have filled our balance sheet. So we can move to filling the transaction matrix, and we will need an hypothesis on income distribution. So we can assume that rho is equal to, I don't know, 75% of GDP. So if this is our rho then WB will be rho times GDP, and this is the negative of this, and profits will be what is GDP, that is less GDP, less wages. Okay, this is to be distributed to business. So here, this is summing up to GDP. Then we need the interest rates. So let's say that the interest rate on deposits is, don't know, 1%. The interest rate on loans is 3%, and the interest rate on bonds is 2%, which are reasonable values. This implies that this flow will be equal to the interest on deposits times the stock of deposits. And this is paid by the banks. The banks earn the interest rate on loans times the stock of loans, and this is paid by the business. And the households get the interest rate on bonds times the holding of bonds, and this is paid by the government. Then the tax rate, let's say the tax rate is 20%, maybe. So the tax, I call the tax tau, and let's say it's 20%. But before I get the tax, I need to compute the dividends and the profits of the banks. So now the profits here are the negative of the difference here. So they are distributed to the households. And the dividends here, maybe I forgot to, no, I used this sigma. So let's say that sigma is what share do they distribute? Say they distribute 80%. So these dividends will be minus the sigma times the profits less the interest payments. I need to have a bracket here. And these are earned by the households. So that this disposable income has to be the sum and this should be a small number. And now the pre-tax disposable income is the sum of all the elements I have in here. So this has not been defined. Let's use this tau. So this would be tau times the wages plus the interest on deposits plus the dividends plus the interest on bonds. And disposable income will be the sum of all this, and it's going to be, looks to something wrong here. yeah, it should start from K4 and end with K11. Okay. So now we need to have a consumption function, an investment function, which are compatible with the GDP that we have obtained. So let's start by assuming a value for government expenditures. So the government is earning 190 in taxes, it's paying 6 in interest. So if we put this at 200, this should be reasonable. And here, this will be the sum of all these elements. So it's borrowing is 14, and this will be the change in the stock of bonds. And this has to be the change in the stock of bonds of the households. Now, consumption, we said, should depend only on these two variables, but this is not so easy to determine, because so we want to find values of these parameters, which gives me a reasonable value for consumption. So since GDP is 1,000 and we have 200 for government expenditure, I'd say that it's reasonable to have 100 for investment and 700 for consumption. So we want our equation for consumption to give 700. And this will depend on the C1 parameter and on a C2 parameter, and we want this to be reasonable. So this could be 75% is the propensity to spend out of disposable income, and let's say 5% as the propensity to spend out of wealth. So for our numbers, this implies 75% of the 770 plus 5% of this. There is something wrong here. Yeah, I have a plus. So not too far from what we want. So a simple way to go is to add a constant to the equation. So instead of having only C1 and C2, I also have a C0. And I put this C0 to be equal to what I want to get less what is implied by my parameters. So now these parameters in the consumption function should give me 700. And here I will have 700 spent on consumption. And we want investment to be 100. So that this will be the net lending, should be the difference between, yeah, it will be the, sorry, it will be, this was the disposable income, and this is the investment expenditure. So we will have minus 56 will be the lending that firms need to fill the gap between profits and investment. and this should be don't know why. Yes, so this will be what they borrow. So the investment equation we had was this gamma times GDP minus beta, and we had the depreciation rate. So let's have a depreciation rate of 10%. Let's have a beta equal to, don't know, 1.1. Actually, let's have it at 0.9. Let's have gamma, should be the speed of adjustment, be equal to 25%. So again, I'm not sure that this is going to give us anything reasonable. So for these parameters, investment will be equal to this gamma times our GDP minus this beta times the stock of capital, which I have in here, plus the depreciation rate times the stock of capital. So it's 125. And again, here I can either try to adjust the values of gamma and beta, or I can add also here another constant. And if I add a constant, let's call this I0, and I put it equal to minus 25, I will have that investment is equal to 100. So here I add my constant, and the constant I0 has to be minus 25. And now we should have everything, but we should check whether the numbers add up.
One question.
Yes.
A constant then that is negative there, it's okay for the accounting.
Yes.
So might, for some theoretical discussion might be a bit problematic or not?
No. It depends on the values of the other parameters. So not even mention that it is negative in presenting the model. Now, this NLH should be the difference between disposable income and consumption. And if we've done everything correctly, when we sum up these numbers, we should have 0, and indeed we have 0. So now we need to check the flow of funds. So this change in deposits has to be equal to the change in loans. And we want the sum of these to be 0. Yeah, I need to have 19. Yes, and so this is also 0. So it looks like the model is completely consistent in the two matrices.
In the taxes paid by the household, also the interest on the public loan.
The taxes paid by households are here. And yes, the public bonds are paid in 8. No, you're correct. We forgot to include K8. Thank you. So this was going to give us a mistake when we try to solve the model. Now this has changed the value of disposable income. So now consumption given by C1 and C2 is 642. So here this needs to be 700 less 642 times 2, and it should be okay. And hopefully everything else is going to be the same because the other numbers have adjusted correspondingly. Okay, so this is how I get the starting values of the variables and the parameters. But they will not be perfect because I'm using the current value of capital to determine depreciation and the current value of the assets to determine interest payments. But now we will want to have a lag. And we are not sure that this, now we have these retained profits, so we're not sure how the model will accumulate this over time and what will be the implications for loans and the stock of wealth. And finally, there is an inconsistency in here, which is that we have this concept of the stock of wealth of the business, VB. I have not listed this in here, but I should list in this VB as the difference between capital and loans. But this VB is not feeding back to anything. So it's not stock which is there but plays no role. But I would suggest that we handle this later. Okay, so now we have completed the setup and we need to go to the simulation. So we want to go to lunch and we do that after lunch. You also wanted to have to try to get the analytical solutions. Okay.
That's difficult.
It depends.
You?
Yes. Yes.
In the line above the Smith equation,
Yes.
you have defined this rate of, well, this difference, right? It's change in
The
L.
change in L. Yes.
You could find this as a variable for the simulation.
No. Yes, we can simply put this to the right-hand side, and you don't need an additional variable for the flow. I'm doing a simplification against what Godlin Lavoie do in monetary economics because they're always careful in having the demand and the supply as separate variables, but then they always have the equilibrium condition so that the demand and supply of bonds or loans is the same. So their approach is much better to explain the fact that we are implicitly assuming that households are willing to buy whatever bonds the government wants to sell, and that the banks are willing to give whatever loans the firms demand and accept whatever deposits households wants to make. But then in more complicated models, you may modify this and have credit restrictions, for instance. And with this setting, you should modify and have a separate demand for loans and supply of loans determined separately. In their setting is already set up to discuss these problems. Okay, so should we go to lunch?
1 hour. We'll come back to 1:30.
Okay.